My role in CAASTRO is twofold. I'm the dynamic theme leader and also the Swinburne node leader. So Swinburne's Centre for Astrophysics Supercomputing is about 70 people. About 50% of them are PhD students, the rest are academics and postdoctoral fellows. And we were invited to become a part of CAASTRO for different reasons. We have Warwick Couch, who's very interested in how galaxies form and evolve. And then on a different dimension, I guess, we have myself, who's been using the Parkes radio telescope to find things that flash or pulse in the sky for many years. And we were joined by Jeremy Mould, who's one of the world's leading observational cosmologists. When I was an undergrad, the university had only just got the first computer that meant you didn't have to use punch cards to do programming. But computer programming was not seen as a hard science. It was seen as a bit of a soft option. And I was actually given career advice against doing any computing. And tragically, I realized that it was actually the most important skill I needed when I actually started trying to do experimental science. So unfortunately, I became a sort of a self-taught programmer. But I always adopted the new languages and paradigms as soon as they came out. So I was a very early adopter of C, C++, and I realized that the supercomputers that we were using to process our data in the early 90s were actually quite inefficient in terms of how much processing they could do per dollar, what it was costing us to run them. And so I started using individual workstations to process our data. And I came up with the idea that if all we did was just go out and buy a whole bunch of workstations, we would be much better off than the Cray or the Convex, or it was the Alliance supercomputer that the different institutions I went to had. And that was because radio astronomy often gives you the opportunity to break a problem into lots of little equivalent problems, and so it parallelizes very well. So when I first went to Swinburne, I realized that if we shut down the Cray and just bought lots of computers in what we call a cluster now, that was actually more efficient. And we got our first computer and did some really good discoveries with it, and then they gave us more money, and so we bought more computers. And at one point we had the second largest supercomputing cluster in Australia. And we've recently bought the G-Star machine as part of a national kind of collaboration. And it's 10,000 times more powerful than the first supercomputer I bought at Swinburne just 14 years ago. So it's incredible how these power is increasing. So I guess supercomputing came about because I needed to process large amounts of data, and I was kind of led there as opposed to being interested in supercomputing first and the scientific problems later. The Pawsey Centre is going to be an incredibly large-scale facility which will, I believe, be at least 10 and maybe 50 times even more powerful than the G-Star computer, although it is kind of like for the whole nation. And some tens of % of that machine are dedicated to radio astronomy. And I think it's going to be quite a task for us to sort of tame the beast, if you like, because I think the kind of clusters we've been used to dealing with are, 100 machines. The Pawsey Centre is going to be in the kind of 1,000 machine type category, and just learning to cope with that amount of data is going to be, and work out what the science is at the end is is going to require us to keep upskilling.